Now this is very critical. We want now to do the computation, so we'll deal first with one ANOVA, then later we look at the two-way ANOVA using the same question, because we have introduced the factors. One type of fertilizer. 3 types of fertilizers are used on 3 groups of plants for 5 weeks. We want to check if there is a difference in the mean growth of each group. Using the data given below, apply one-way ANOVA. Test is 0.5 significance. So number 1, we identify our ANOVA, our statistical ANOVA. So hypothesis, we need to create our hypothesis. So we have HO equals to, so our null hypothesis, HO1 equals to HO2 equals to HO3. And our alternative hypothesis, HA, is not equals to is not equals to HA1 is not equals to HA2, HA2 is not equals to HA3. So we have identified our null hypothesis. That means the mean of the 3 fertilizers are not equal. They are different. Right. Now we do the means. So can we get the mean for all these 3 groups? So what we do, let me create the table. Let's have a table. There are how many? 3. So 3. So we have fertilizer. So let's use that count. Fertilizer. So A, B, and C. So we have 6, 8. I'm just inputting everything for all the 3. 6, 8, 7. Then 2, 8, 12. 7 or 6. 3. 4, week 3. We have 4, 9. 4, 9. 7. We have week 4. We have 5, 11. 10. Then we have week 5, the last week. For week 5, we have 3, 6, 12. 3, 6, 12. Then we have week 6. Oh, day 6, not weeks. These are days. Day 6, we have 4, 8, 10. So that is it. So can we get the mean? For us to get the mean, we get the totals. So can we get the total for all of these? 6 plus 4 plus 8. I should have used the let me do the computation using the calc. So 6 plus 4 plus 8 plus 5 plus 3 plus 4. That gives us 30. So we get the total for all, and then we do the mean. And then for B, 8, 12 plus 9, 11 plus 6, 8. That gives you 54. 7, 6 plus 7, 10 plus 12, 10. 52. Alright, so to get the mean, so I think we'll do the computation just here for mean. So the mean, which is actually x small, no, the mean will be x, let me call it x small, equals to 30 divided by 6, or the formula. So the formula for the mean will be sum of x divided by k. Divided by k, the number of. So we have 30 divided by 6. Okay, n. This gives us 5. So the mean for the first one is 5. The mean for the second one is 54 divided by 6. That is how many? 9. 54 divided by 6. 9. So the mean for this is 9. And then for the other one, 52 divided by 6. 8.6. Alright, so these are the means. So number 1, determine the mean for each and every group. So we have the mean for each and every group. Number 2, we determine the mean for all groups. So mean, or I call it overall mean, will be 30 plus 54 plus 52. That gives you what? 30 plus 54 plus 52. That gives you, just a minute, 30 plus 54 plus 52, 136. Divide by 6. No, divide by the overall mean. Divide by 18. So what do we get? 7.5, 7.6. So the overall mean for the all data is 76. Now, number 2, we now get the variance. So we want to get the sum square between. So we start with sum square between. So sum square between, it should be very easy for us to tabulate. So we have the mean for the 3. So the mean for the first one is 5, 9, 8.6. Alright, we get the deviation. So mean minus x minus mean, the overall mean. So our x is 5 minus our overall mean is 7.6. So you say 5.6, 5 minus 7.6. What do you get? Negative 2. So you get negative 2.6. So 9 minus 7.6, you get 1.4. Then finally 8.6 minus 7.6, you get 1. Get the square of this. Get the square of this, so that we get the sum square between. So we are getting the sum square between, and this will be the sum square between, power 2. So 2.6 times 2.6, so that we can eliminate the negatives. 2.6 times 2.6, we get 6.76. 1.4 times 1.4, you get 1.96. And then 1 times 1, you get 1. So we get the sum square of this between is 6.76 plus 1.96 plus 1 gives you 9.72. Wow. So the sum square between is 9.72. Right, we move to the next one. Sum square between, sum square within, sum square within. Wow. So sum square within, we do it for all. for the 3. Sum square within. So we'll do for the first, then we go to the second, then we go to the third. So this is for A, X. So X minus mean. X minus mean power 2. So this is how you incorporate this. So we are getting the sum square within. So what are the values for the first one? Just copy this. It's 6 tables. So I'm copying this. They bring it here. Alright. Our mean was 5. So 6 minus 5. So we'll just play with the mean. So 6 minus 5, 6 minus 5, 1, 8 minus 5, 3, negative 1, 0, negative 2, negative 1. Get the square of this. 1, square of 3 is 9, 1, 0, 4, 1. Get the total. So we get the total for this. Gives us how much? We're getting 10, 11, 16. So 10, 11, 16. We move to the B. Again, we copy B. Copy B. So this is B. Again, the mean was 9. So 9 is the mean. So we play with our figures here. 8 minus 9, negative 1, negative 3, positive 3, 0, 2, negative 3, negative 1. Get the square of this. 1, 9, 0, 4, 9, 1. Get the total. So our total here is 10 plus 10, 10 plus 10, that's 24. So we have 24. Lastly, we come to C. C, we get the total again. copy, come and paste down here. Alright, again, what was the mean? 7.6. so 7.0 minus, so it will be negative 0.4. 7.6, 6 minus 7.6, you get 1.6, 1.6, negative, move on, 7, you get negative 0, 7 minus 7.6, you get negative 0.6, 0.6, you get 2.4, here you get minus 7.6, 4.4, here you get 2.4. Alright, we get the square of this. This will be 0.36. The square root of 1.6. The square of 1.26 is 2.56. The square of 0.6 is 0.36. The square of 2.4, the square of 2.4 is giving us 5.76. 5.76. The square of 4.4, the square of 4.4 gives us 19.36. And then the square of 2.4, we have 5.76. 5.76. Get the total. So our total will be 0.36. So that is 0.72 plus 2.56. 2.56 plus 5.76, 5.76 plus 5.76 plus 19.36, 19.36. That gives us 34.16. Right. Remember the formula? Now, so the total sum between, can we get the sum square within gives us how many? We say 9.7, 16. So you have 16 plus 24 plus 34.16 gives us 74.16. Right. Correct. Now, can we now get the necessary? So we build on the table. So there is a table here that will help us summarize everything. In the next few minutes we are done. So we summarize this in this table. Okay. Source, sum square, then we have degree of freedom, then we have mean sum square, then we have f value, then we have BB. So can we apply this? So we have between, sum between, source group between groups, and within groups. So our sum between groups is 9.72. 9.72. Our sum within groups is 74.16. The degree of freedom is 3 minus 1. It gives us 2. The degree of freedom for this is 18 minus 3. It gives us 15. Wow. And then we now come to mean sum square. So 9.72 divided by 2. What do you get? 9.72 divided by 2 gives us 4.86. Then here we have 74.16 divided by 15. 74.16 divided by 15 gives you 4.99. Right, we get the f value. So f value equals to 4.84 between, mean between 86 divided by 4.94. 4.85 divided by 4.94. Second division, 4.94. We have 0. It's giving us 0.098. 0.098. Alright. So we now go to the F statistics, F table, so that we get the F critical. What is in the F critical? So F critical, our degree of freedom 1 versus degree of freedom 2. So this is the representation. So we have degree of freedom 1 is 2, degree of freedom 2 is 15, so 2.70. So we are getting the F critical is 2.70. Now we said if F critical is greater than F statistics, you reject. So compare. So are we rejecting or not rejecting? So we will fail to reject. We will reject. We reject the null hypothesis. Now we can subject this now further to H hoc, hard hoc, post hard hoc. So that now we know at what point are the means different. At what points are the mean different. Thank you and enjoy the ANOVA.